In this video, we are going to take a look at arc length and sector area. We're going to take a look at this circle. So within the circle, let's think about it as a piece of pizza. I'm going to cut out a piece of pizza. Within this piece of pizza, we have this inside region, which you can think of as like the cheese, pepperoni, etc. That inside part we call the sector area. And then the crust, the part that normal people don't like to eat, the crust piece we call the arc length. Okay, at least in my opinion, that's how it is. So we're going to take a look at how do I find the length of that arc, how do I find out what that physical piece of it is around, and then also what is the area inside of it, what is that cheese? Or if you think about pie, you've got your pie crust and you've got like the cherry filling. So that's the piece that we're looking at, keeping in mind that it is two-dimensional, not three-dimensional. So let's take a look back at what you know about circles themselves. So here we have a nice circle. And we're going to look at the entire pizza. If I wanted to find how much of that crust I was eating, the distance around the outside, what do we call that? Circumference. And do you remember the formula for circumference? C equals 2 pi r. So if I was trying to find out how much of the pizza I was eating, I'd have to find my radius from the center out, double that, and then multiply it by pi. That's going to give me the circumference, the entire piece of the outside, the crust part. That's how much I'm going to throw away. Then, there's a badly drawn circle. Instead, I might look at, well, what is the area inside my pizza? All that yumminess, the cheese and toppings and all of that. What do we call that of a circle? The area. So now you have to remember the formula for area. Pi times my radius squared. So again, finding that radius value, squaring it this time, multiplying by pi will give you the area. However, back to the original problem here, I'm not looking at my entire pizza, I'm just looking at a piece of pizza. I want to find out how much of that pizza I'm looking at. So that we call arc length. So we're going to look at how do I find the formula for the arc length. And then also we're going to look at sector area. Now, circumference, 2 pi r, area, pi r squared. Is it going to be more of that or less of that when I start looking at a single piece? It's going to be less. It's going to be a portion of it. It's not going to be the whole thing. So back in geometry, you should have learned that arc length is theta over 360 times 2 pi r. The 2 pi r comes from your circumference formula, and then it's a portion of it, which is the theta over 360. Versus for sector area, area is theta over 360. It's that angle that we're eating out of the entire 360 degrees, and I multiply that by pi r squared. Again, the pi r squared piece coming from the whole circle. So this was in degrees. Now we've already talked about radians and what radian measurements are. Because realistically, if you think about this 360 degrees, okay, I have to measure my physical angle inside my pizza to see what it is. But it's much quicker if I work with radians. So these two measurements are based on if my angle is given to you in degrees. Now let's look at what if it was in radians. So now, length equals something times 2 pi r. This time, instead of it being 360 degrees, because it's a circle, in radian measurements, a whole circle is 2 pi. So it's going to be theta over 2 pi. Area, same type of scenario, theta over 2 pi times that pi r squared. Now for arc length, this is really helpful because things simplify. This 2 pi r piece, I can put it as a fraction. And if you remember back from rationals, we multiply straight across the top and across the bottom. But before we do that, the 2 and the 2 cancel, the pi and the pi cancel, and all that I'm actually left with, arc length, is theta times r. So I have to find my theta, multiply it by my r, and that's my arc length. In sector areas, not quite as much simplifies, but at least the pi's do. So for this one, a couple of ways you can write it. I like to write it as 1/2 theta r squared, or you can do theta over 2 times r squared, or theta times r squared over 2. All of that works. But both of these work with radian measures. So if I give you a radian measurement, instead of having to convert it to degrees and then use that bulky formula, I can use these two formulas, and it's going to straightforward tell me what my arc length is and what the sector area is. So we're going to do a quick example with this. So given this picture, I want to find the arc length and sector area. I purposely gave you one where your angle measure is in radians, so I can use the two new formulas. If I give them to you in degrees, feel free to convert them into radian measures, then you get to use these two easier formulas. If you want to use your degree formulas, if you know both of them, that's fine, but being able to do the conversion piece may help you along the way, make things a little bit easier. So I know arc length is theta times r, and I know my area formula is 1/2 theta r squared. So now I'm just going to plug in my information. So my arc length is theta, which is pi over 4 radians, times my radius, which is 4. 4 over 1. 4's cancel. Therefore, my arc length is just pi units. 3.14159, etc. That's how long this arc is. Now for my area formula, again, I just plug in my information. That's 1/2 theta is pi over 4 times my radius squared, which is 16, and I'll put that over 1 because it's 4, so 4 squared is 16. Now I will simplify. 4 goes into 4 once, 4 goes into 16 4 times, and then 2 goes into 2 once, and 2 goes into 4 twice. So when I multiply across the top, I get 2 pi, and then my label here is units squared because it's area. So exact answers, no approximations. This is exactly what my answer is. And you should be able to give these to me exactly. So that distance all the way around is 2 pi, or that, excuse me, the area of my inside region, so this region inside here, just inside that piece of pizza, is 2 pi units squared. Lastly, I should be able to give you information, and you should be able to find different pieces that you need. So keeping in mind what you know about arc length and sector areas, I'm giving you some information. Sector has a radius of 8.2 centimeters. Its arc length is 13.2. I want to find the area of the sector. So I'm giving you a radius and an arc length. I need the area of the sector. So the first thing I might write down is, well, what's the formula for area of a sector? Area equals 1/2 theta times r squared. So take a look at what I'm giving you. Am I giving you theta? No. Am I giving you the radius? Yes. So area equals 1/2 theta. My radius is 8.2. And then I'm going to square that. So my goal is to find what my area is. That's what the question is asking for. So I have to find theta. So now I have to look at the problem. What else did they give me? They must have given me more information. They did. They told me the arc length is 13.3. So now I'm going to go back and put my arc length formula. Arc length equals theta times r. Not a, I'm sorry. Arc length, L, equals theta times r. So I plug in my arc length, which is 13.3, equals theta times 8.2. Now, my unknown here is theta. That's what I need here. Now I want you to realize that I'm actually using the radian formula, but nowhere in this problem did I give you radians. And I also didn't give you any degrees, which means I can use whatever formula is easiest to use. So I am definitely using the radian formulas for these. So now I take a look at what I have. I need to find my theta, so I have to divide both sides by 8.2. So theta is 13.3 divided by 8.2. So therefore my theta is 1.623. That value is not exact. You need to make sure you keep that exact value, because now I have to take it and plug it in for theta. And it has to be exact so that my answer is more exact. So now I plug that theta in, and I end up getting my area equals 1/2 times 1.623 times 8.2 squared. I type all of that into my calculator, and I get 54.5. My label was in centimeters, and it's squared because it's area. So in this case, again, I did not give you what your angle was. I had to find it. It doesn't matter whether you used your degree formula or your radian formula. But I'll tell you what, I'm going to pick my radian formula most of the time, because I don't want to have to deal with that theta over 360 piece.